Now, we're going to move into working with things called relations and functions. And these are the goals for this section. We're going to define what these things are, relations and functions, and look at this thing called mapping. And then we're going to determine whether a relation that we have been given is a function. I want to start by reviewing and connecting this with straight lines. What we've been working with are linear equations. Now, if we look for just a moment at the slope-intercept form, we have y equals mx plus b. We are going to use this oftentimes in graphing. We would be graphing ordered pairs. And these ordered pairs have the coordinates x and y. When we graph them, we can see in the picture, or perhaps even in the equation, that there's a relationship between x and y. If we were to choose an x, we could plug an x in and get a y out. And that's the relationship I want you to focus on. We could plug in x and get y out. We're going to call x the independent variable. We pick it. Independent. And we're going to call y the dependent variable. We take what we get. So independent, you get to choose. Dependent, you take what you get. It's what comes out. Now, a relation is simply, thinking about these lines, a relation is simply a set of ordered pairs of real numbers. I'll just write a set of ordered pairs. So, for example, something you're probably familiar with, we could look at lattes. If you were to purchase a single shot 16-ounce latte, a typical sort of price, actually a very good price, would be something like $1.75. If, on the other hand, you were to get a double, otherwise the same 16 ounces and so on and so forth with your flavors, just a basic latte, you might pay $2. If we were to let x be the number of shots of latte that or of coffee that you have in your latte, you're going to choose that. Then our y would be how much money that we pay. The amount that we pay depends on how many shots of coffee we choose to get. We can write as a relation the ordered pairs, 1 for 1 shot of coffee, 1.75 for the cost, and another ordered pair, 2 and 2.00. So a relation is simply a set of ordered pairs. Now, a function is a special kind of relation. And what's special about it is, to put it in a quickie sort of way, each x has exactly 1 y and no more. It matches up with exactly 1 y and no more. So we're really talking about coordinates here in our ordered pairs. I'll just recite to you what it's more carefully stated. A relation in which for each value of the first component of the ordered pairs there is exactly 1 value of the second component. Each x has 1 y, no more.